This is section 9.3, part B, polar and rectangular forms of equations. The conversion of a rectangular equation to a polar equation is fairly straightforward. You're just going to replace your x value with r cosine of theta, replace your y value with r sine of theta, and then simplify the resulting equation using algebraic manipulations and trigonometric identities. To identify the graph of each rectangular form, you are going to graph it in polar form. Support your answer by graphing it also in polar form. When we need to write a polar equation in rectangular form, we also make use of the relationship that r squared is equal to cos x squared plus y squared. We also know that y is equal to r sine of theta, and we know that tangent of theta is equal to y over x. The process, however, is not as straightforward as converting from rectangular to polar form. So we need to identify the graph of each rectangular equation, then write the equation in polar form. So in rectangular, x minus 4 squared plus y squared is equal to 16 should get you a circle. Now we actually need to write this in polar form. To do this, we replace the x's with r cosine, replace the y's with r sine. On the left, we do have a monomial squared, so instead we can write that twice. Then we have r sine of theta squared, so we can square each piece separately. So this will be r squared sine squared of theta is equal to 16. We are going to FOIL. So r cosine times r cosine gives me r squared cosine squared of theta minus, if we do outside, this will be minus 4r cosine of theta. Inside will be negative 4r cosine of theta. And last, negative r gives me a positive 16. And we still have the r squared sine squared of theta is equal to 16. If we combine like terms, and if we take this 16 to the other side, right now it's positive. To move it, we would need to subtract it. 16 minus 16 gives us 0. Now when you're writing equations in polar form, you either want to get the r completely by itself or you want to get theta by itself if that's the only variable you have. Because we have r's and thetas, we are going to try to get the r's by themselves. So anything that has an r squared, I'm going to keep on the left side. Anything that just has an r, I'm going to take to the right side. Because that was a negative 8r cosine, when I move it to the right side, it does become positive. Now if we look at the left side of the equation, we notice both parts have an r squared. So I'm going to go ahead and factor out that r squared from both pieces. Now hopefully at this point you recognize that we do have a Pythagorean identity. Remember, sine squared of theta plus cosine squared of theta is equal to 1. So we do have r squared times 1 is equal to 8r cosine of theta. When we're writing equations in polar, we do want it to just be r equals and then an equation. So we can divide both sides by r. This will cancel one of my r's here. This will cancel my r here. And we will be left with the equation of r is equal to 8 cosine of theta. Okay, if we were to identify this graph, y equals x squared, if we were to graph this, would be a parabola. Now we need to convert from rectangular to polar. Again, y is equal to r sine of theta. X is equal to r cosine of theta, but that is squared. So we have r squared cosine squared of theta. We are trying to get the r by itself when we're writing an equation in polar form. So let's go ahead and divide both sides by an r. These are going to cancel. This will cancel 1 here. So we have sine of theta is equal to r times cosine squared of theta. Again, we're trying to get that r by itself, so we're going to divide both sides by the cosine squared. So we know the sine theta over cosine squared of theta is equal to r. Now we have to think back to when we were manipulating our trig identities in chapter 5 and think about how to simplify this expression. Now I can write this as 1 times the sine of theta over the cosine of theta times the cosine of theta, because cosine squared just means cosine times itself. And when we're dealing with multiplication, we can break this up into 2 different fractions. So I can say 1 over the cosine of theta times the sine of theta over the cosine of theta. 1 over cosine is the secant, and sine over cosine is tangent. Because we no longer have any fractions, this is in the simplest form. So r is equal to secant of theta, tangent of theta. If you remember back from section 1 of this chapter, if we had an equation of theta is equal to pi over 6, this would represent just a straight line. So when we get this converted back to rectangular form, this should be an equation of a line in rectangular form. So we need to figure out what the equation is in rectangular form. We have theta is equal to pi over 6. Remember that we know that the inverse tangent of theta is equal to y over x. Now our theta measure is pi over 6. So if you go to your unit circle at pi over 6, our y coordinate is at 1/2. Our x coordinate is radical 3 over 2. So if we simplify this, if you have a fraction over a fraction, remember you flip the second one and you multiply. Our 2's are going to cancel. This becomes a 1, this becomes a 1. So we're left with 1 over radical 3. But you cannot leave a radical in the denominator, so this would become radical 3 over 3. So we know that y over x is equal to radical 3 over 3. When we need to write an equation in rectangular form, remember it's usually y equals and then some value. So we do need to get the y value by itself. To do that, we are going to multiply both sides by x. And we're left with a form of y is equal to radical 3 over 3x. This would be a graph that has a y-intercept of 0 and has a slope of radical 3 over 3. If we remember back again to the first section of this chapter, if we have an equation in polar of r is equal to 7, this will be an equation of a circle that has a radius of 7 and is centered at the origin. Now to convert this back into rectangular form, we know that r is equal to the square root of x squared plus y squared. So we can replace our r with what it's equal to in rectangular form. Now to get this in rectangular equation, we do need to get rid of that square, the square root. And to get rid of square roots, you do square both sides. So we have x squared plus y squared is equal to 49. This is what we're looking for because we already identified that this should be a circle. And a circle is in the form of x minus h squared plus y minus k squared is equal to r squared. But since we already identified the center should be at this origin, we're not adding or subtracting anything to our x and our y. And this equation does have a radius of 7. We did not graph these. These were graphed in section 9.2, but an equation of the form of r is equal to negative 5 sine of theta will also be a circle. It will just not be centered at the origin. So we are also going to be looking for the form of x minus h squared plus y minus k squared is equal to r squared when we are done in rectangular form. Again, we need to remember that we know what r squared is and we know what r sine of theta is. Right now on the right side, we do not have an r with that sine of theta, but we can multiply the entire equation by an r. So on the left side, r times r gives me r squared. Negative 5 sine of theta times r is negative 5 times r sine of theta. Now we do know rectangular, polar to rectangular, r squared is equal to x squared plus y squared. And we know r sine of theta is equal to y. So we can replace that negative 5 with a y. Now we need to get this an equation of a circle form. So I'm going to take everything to the left side. And we are going to have to complete the square with our y's. So we have x squared plus y squared plus 5y is equal to 0. Remember, when you are completing the square, we need to find our c value, which is b over 2 squared. Our b value is the value in front of the variable without an exponent. So in our case, it's going to be 5 over 2 squared, which is 2.5 squared, or 6.25. So we're going to add 6.25 to both sides of that equation. Now when we go to factor this part, we're going to have x squared plus y plus or minus some value squared is equal to 6.25. Remember, whatever's inside the square here can be inside the square down here. So our equation of our circle will be x squared plus y plus 2.5 squared is equal to 6.25. If you remember back to your circles, we know that the center will be at 0 and negative 2.5. When you pull them out of the parentheses, they change the sign. The radius of our circle will be the square root of 6.25, or our radius will be 2.5.